welcome back to our YouTube channel. So from this video onwards, we're going to start a new playlist in our YouTube channel, and the name of this is Data Structures and Algorithms. So in this playlist, we are going to cover all the major and fundamental topics of data structures and algorithms that will be helpful for you for preparing for your dream job. And yes, in this field of data science and machine learning, DSA is very important because it will help you to solve various problems, okay, related to your field. So now let's begin with the first video of data structures and algorithms, where we'll be taking an introduction of what data structures and algorithms are and how they are useful, and some of the basic types of data structures as well we are going to cover. Okay, so basically data structures are nothing but, let's take a small example that you want to build a house. So if you want to build a house, the first step that you will do is you will collect the material for building the house. So you will collect the bricks, you will collect cement or wood or whatever that is required, and then you will add some home building instructions. To the construction worker, you will tell that I want a 2 BHK house or a 3 BHK house. My hall should be north facing. Then I want this much area of kitchen, okay, etc. etc. So when you add the material and the instructions together, you will build a house. Similarly, whenever you want to build a software, or for example a program, a small program, then the basic step is to add the material and the instructions. So the material in this case are the data structures, and the instructions are nothing but the code instructions. And when you combine these two, you will build a software, okay, or a program. So here, these are the data structures. As you can see, these are nothing but the blocks, okay, or the material that are required to build a software or a program. So a data structure is a storage that is used to store and organize data. It is a way of arranging data on a computer so that it can be accessed and updated efficiently. So according to your use case, or according to the type of program you want to form, or the type of data you want to store, you have to choose the data structure accordingly. Okay. So data structures are building blocks or raw material for any software program. Okay. So this is a very clear definition of what data structures are. Okay. They are just a storage that is used to store and organize the data, and by using which you can access and update the data efficiently. So these are some of the basic ones, like you have the array, the linked list, and the tree. Okay, so these are the basics that are covered in all programming languages, but they can be a minor difference. For example, an array is present in Java and C++, but the same array is present in the form of list in Python. Okay, the functionalities are same, but there can be a minor difference. Okay, then you don't have linked list in Python, but you have linked list in C. Okay, this was an example. Then you have tree. So there are certain minor differences in the data structures, but the functions that they offer are almost the same. So data structures are nothing but the containers that store data in a specific layout. Okay, and the layout is specific to each programming language. Okay, so according to your use case, you will choose the layout that you want to store your data in. So in our previous further videos, we are going to see that in which use case you can use which data structure and how you can store that in these data structures. Now we're going to see the classification of data structures and all the data structures that are covered in programming languages. So the first one is the major classification of data structures is done into two classes: primitive data structures and non-primitive. So what does primitive data structure mean is that they are present in the basic form. Okay, just a second. Yes, so primitive data structures are present in the very basic form. Okay, you can use them. They are inbuilt. Okay, they are inbuilt in your programming language, and they are the very basic. Okay, they do not depend on any other thing or any other data structure to for them to be independent. Okay, so basically they are independent of any data structure. Okay. So the examples of these, there are four data structures that are primitive data structures: integer, float, character, and boolean. So example of integer is nothing but values like 10, 2, 15, 285, okay, etc. Float, you have 8.5, 15.2, okay, then 25.354, etc. Then characters 8, small, okay, all the letters and words, and it can also contain paragraphs, okay, single letters as well. And boolean, you have two values, false and true. Okay, so these were the primitive data structures, okay, that are independent and they are very basic. Now the non-primitive data structures are such data structures that are dependent. And on whom they are dependent? They are dependent on the primitive data structures. Okay, non-primitive data structures are simply dependent on the primitive data structures. And you will see that, okay, you will see that ahead, that how they are dependent. Now there are two types of non-primitive data structures. First is the linear and non-linear. So what does linear mean is each value in the data structure is connected to the next value. This is called as linear. Okay, and non-linear is that it is not compulsory that each value is connected to the other value. So example of non-linear data structure is a tree and a graph. Okay, so a tree is nothing but, as we saw in the previous example only, you have this tree. Okay, you have this tree, and graph is also of similar form. Okay, this will be called as a graph. So you can see tree and graph, you can have as many connections as possible over here. Okay, in the tree and graph, basically they are not linear. So tree and graph are the non-linear data structures, and linear data structures is further divided into two types: static and dynamic. So what does static and dynamic mean? Just a second. So static is basically that once you fix the size of these, okay, once you fix the size, you cannot add any other values. So suppose a array, if I fix the size of array as 4 while creating the program, then you cannot add the fifth element over here. Okay, the size will remain 4. But in the case of Python, array, which means list in Python, is dynamic. It is not static. Okay, so as I told you, there are certain minor differences in the data structures according to the programming language, but the functionality is just same. So the static data structure that we have is array, which is also called as list in Python. Okay, and there is a way of executing dynamic arrays also, but the basic nature of array is static. Now in dynamic means that you can change the size according at the time of execution only. You can change the size. Okay, there is no fixed size of the dynamic data structures that you have to set. Okay, so there are three dynamic data structures. First is the linked list, then stack and queue. So in linked list, as we know, there is a pointer and a value. Okay, and all these are connected to each other. Then you have the stack. Stack is this. So you add this value first, second, third, fourth, but the last one will be the first to come out. Okay, so this will be last in, first out, LIFO. Similarly, Q is nothing but a normal queue wherein you follow FIFO, that is first in, first out. Okay, so these were the classification of data structures, where you can see we covered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data structures over here with their classification. Okay, so I hope you found this video interesting, and in the further videos we are going to cover more and more topics of DSA. In the next video we are going to look at the time complexity concept and the big O notation in DSA. Okay, so if you like this video, then do subscribe to the channel, because in this playlist we are going to cover all the topics of DSA that can be very useful to you. Thank you for watching.